Hello, what's happening? This is a failed print. But it's not even the first one. This is a second attempt at printing after I already cleared up a previous failure. But let's back off a little bit and absorb it all in. Not even a week after I posted my video on YouTube, shamelessly praising this trusty but aging Ender 3 Pro as the best thing since sliced bread, I came into the printing room to find a failed print in the act. What should have struck me immediately was the absence of any significant spaghetti. Just a couple of printed pieces being thrown about the bed, and the printer going through the motions, without printing anything, with an apparent clogged head and with a piece of model stuck to it. I tried to manually push the filament through the system, with no effect. I also failed to pull back the filament through the extruder, even after using unreasonable strength. Yeah, I snapped the filament. Something horrible must have happened at the nozzle. After letting the printer cool down, I started disassembly, beginning from the nozzle and making my way towards the extruder. At the nozzle, a big clump of PLA formed between the brass nozzle and the Bowden tube, and that anchor was keeping me from pulling the filament back. The Bowden tube was also in very rough shape. The head assembly coupler had chewed so much of it that the piece that was inside the heating chamber was barely attached to the rest of it. I had to cut it off. Reaching all the way back to the extruder, I found the final nail in the coffin. The plastic arm that provides tension had snapped.
This printer was toast.
Hastily, I installed a backup nozzle I had from Creality, shortened the Bowden tube, and superglued the hell out of the extruder arm because it's the type of plastic that is very sensitive to CA glue. Yeah, I know, I broke my own rule here and foolishly hoped this horrible bodge would hold until the immediately ordered replacement parts arrived from China. It absolutely didn't. The tensioning arm snapped minutes into the first printing attempt. That is where we came in. But now it's time to take the filament out, shut down and unplug, because dirty packages have arrived from the Far East. First thing I got was a new extruder, made out of metal this time. I also got a high quality Bowden tube, because the original was not only too short now, but bothered me for a long time, so I wasn't shedding any tears seeing it gone. With the same occasion, I also got 3 other upgrades that weren't strictly necessary. I got a few generic hardened nozzles, silicone feet for the bed, and a Z-axis rod support upgrade. But let's not stand on the ceremony. Just maneuver up the print head assembly and crack on with the repairs. This assembly is pretty straightforward, except for the fact that almost every screw is different, for different reasons, so you need to keep a mental note of it and put them separately. The sensor and cover for the head assembly are held with 2 identical screws. Once everything is cleared away, I can remove the coupler and the nozzle, but not before taking out the silicone insulator. This could be changed with a new one, but I don't see the point. Maybe I'm wrong, but I'm gonna keep using the original one until it no longer stays in place. Removing the nozzle reveals one of the common ways these printers get clogged up. When the tube and nozzle get separated, a space forms that gets filled with molten plastic. The printer will still work, at least up to a certain volume of the occlusion, but it will get harder and harder to push plastic through this mess until the extruder will reach a point where it will fail to push anymore and just start chewing on the piece of filament that is stuck in front of it. I chose this extruder because it looked like a direct replacement for the original. I don't want to change or upgrade the system. I don't want to introduce extra complexity, just more of the same in a stronger material will do just fine. Inspecting the extruders side by side confirms this is almost one-to-one replica, except for some missing inserts that are no longer necessary because you can now screw into the metal directly. I also measured the diameter of the gear that comes with the new kit, because I would really like to keep the original that is attached to the Z motor axis. Gears prove to be virtually the same, so there's a green light. I will still do a calibration test with the new extruder, but I don't want to change the existing gear simply because I don't have a puller small enough to release it from the axis. And a proper sized gear puller is the only way to do it without risking damage to the motor itself. And yes, as you can see, each and every piece of the extruder is identical to the old one. A crude mock-up of the old extruder shows how simple the system is and how it works. You have a gear that is directly powered by the motor, a wheel that maintains pressure, and that's pretty much all you need. Now let me assemble the new extruder. The only difference that I found is the absence of this knob that keeps the tensioning spring captive. I don't know why they didn't do it from the mold, but I have to put in a small screw for the roll. A closer look at the damaged extruder piece makes me shake my head in disbelief. Had I knew this extruder is so hollow and flimsy on the underside, I would have changed it a long time ago. I just noticed the extra crack along the insert that channels the filament through.
What's with that?
The piece is under tension in the other direction, I think. So why would it crack in this direction? It makes no sense, unless this was cracked from when the metal insert was shoved in at the factory. Enough about that. Time to measure the old and cut the new Bowden tube to length. As a side note, I was way too generous with the new tube's length and I had to shorten it later. But shortening is free, while replacing is costly. Always inspect the cut. It has to be as perfect as possible, flat and clean, because this is, unfortunately, a mating surface. I'm taking out the old tube and we're gonna see them side by side under the microscope. It doesn't look like much of a difference in this footage, but in real life, when inserting a piece of filament, the new tube feels like a tight fit, while the old one feels like the filament is just dangling inside, hitting the sides. I'm so cheap and lazy, I'm just gonna use the old cable ties and shove the new tube in. How about that? Time to start putting it back together, starting with the new extruder. And don't forget to put the new tensioning spring in. The Bowden tube and the nozzle need to meet in the heating chamber and mate perfectly. This system is inherently flawed and it's never gonna be perfect. Having a mating surface between two different materials, from which one is flexible and somewhat compressible, was not a bright idea to begin with. It makes the nozzles cheap and simple, but the system is always going to be degrading, as the Bowden tube naturally gets pulled back over time. What I'm showing here is what I call dress rehearsal. Fancy close-ups, angles and taking my time during the real assembly will not be possible because everything will come together at high temperature. Okay, rehearsal is over, but before I go on with the real assembly, let me put the new silicone feet in. What I use now are not the original bed springs, not even the yellow upgrade, but some blue springs that are extremely stiff and served me extremely well from the time I put the sensor upgrade in. I don't know what I was thinking here. This was completely not needed. Messing with the bed not only set me up for hours of dialing in later, but also put unnecessarily stress on the printer because I had to rotate it several times and rest it on its sides in order to be able to film.
Smash!
The last thing I'll do is another unnecessary upgrade, the Z-rod support upgrade. This will be complicated just by the fact that I was unwilling to disconnect the rod from the motor coupler, so I had to get creative. Now let's get the printer in its normal spot and clean it before the real head installation. I tried grossly getting the bed level with a ruler before leveling and fine-tuning the bed with the printer sensor. Remember your ABC? Always be cleaning. Time to roll them. This is executed in one take because the high temperature is no joke. I do this at 240 Celsius because that's the highest temperature I print at ever. It's necessary to heat up the chamber in order to be able to floss out any old contaminants, no matter at what temperature they melt. Don't forget to take the bed out, or better yet, protect it by covering it with a silicone mat like I did here. If the superheated nozzle would be to fall, no damage will be done. I'm gonna use the old Bowden tube for flossing. It's only fitting to use it as a rag. If you use the new tube for that purpose, make absolutely sure that you inspect and clean the ends after, or the whole cleaning step was in vain and the mating will be compromised. The socket I'm using to secure the nozzle is quite a hefty chunk of metal, but even in poor contact with the heat source for less than 8 seconds, by the end it's uncomfortable to hold with thin gloves. 240 Celsius is no joke. You need to work as fast and as precise as possible and not burn yourself. Now for the procedure. What I do here is screwing the nozzle as far as it goes and then back off a whole turn. The reason will be obvious later. It's time for the coupler and the Bowden tube that I shove all the way in, just as I did during rehearsal. When I tighten the nozzle next, I'll put some compression into the tube, somewhat inhibiting the potential of it separating and letting a block of molten plastic form between the tube and the nozzle. Is it perfect? Absolutely not. But it works for the most part. As I tighten, I should feel the tube resisting and informing me the Bowden is inserted all the way in. Don't go overboard with any of this if you deviate. You'll just push and tear the tube into the coupler's teeth. It's a matter of balance. More is not necessarily better. Next, I drop down the temperature to 200 Celsius and I manually push some PLA filament through the extruder. I want to make sure the head is functioning. The tube is not pinched or buckled. Everything looks good so far. When all is done, it's time to cool down. And after the head is cool enough to touch, reinstall the silicone insulator, the cover and the sensor just as in rehearsal. It's time for the extruder calibration now. This was never done on this printer because if it works, I don't mess with the factory settings. But with the new extruder, even with the old gear in place, it's time for a new start. At least see how far off are we. What I do is take a piece of filament, leave enough slack at the end to securely enter the extruder, but not enough to reach the printing head. Next I will measure a 100 mm segment and mark it with my marker, both start and end. Extra, I'll mark the point that is at 90 mm under extrusion and 110 mm over extrusion, and also the 95 and 105 points with a different colored marker. This way is extremely easy to eyeball where the extruder stops. I will have to bring the head to temperature or the printer will not allow me to extrude at all, because it doesn't know the filament will never reach the nozzle. With the filament inserted up to the starting mark, I advance the extruder 100 mm from the printer's menu. Would you look at that? It stopped short at 95 mm. Let's see the factory settings that yielded this result.
93 steps.
Wasn't this supposed to be at least 95 from factory? I always thought this printer works better under extruding, but this is way under my expectation. Anyway, let's do some simple math. If 93 steps resulted in 95 mm, how many steps would result in 100? It should be 93 times 100 over 95, with a result of 97.8. And don't forget to store settings. Always be storing settings. Let's see if my math is mathing, and retry the calibration test. Will it extrude 100 mm? Yes sirree, 100 mm on the nose. Let's move on to the bed leveling. Personally, I don't just let the printer find the bed level and move on. I obsess about the bed being as level as possible before taking into account the variations across the surface. To this end, I pay attention and write down the numbers the printer reports for each of the 16 points measured on each pass. I'm only interested in the first and last point of the first row and their equivalents on the third row. I feel these four are closest to the 4-level screws position. After I write down the values for these corners, I adjust down the corner that has the highest value and then restart the bed leveling. The values themselves are meaningless because they are referenced to the middle point first contacted when searching for the bed. The Z offset set in the printer settings is also taken into account. Nevertheless, this process is iterative and I don't stop until the printer reports all 4 corners at almost the same value, whatever that may be. Is this level of finesse required for a perfect print? Absolutely not. Probably not. Maybe. After I am satisfied with the bed leveling, it's time to set a proper Z offset. This value will be higher or lower depending on how high and low are the sensor and the tip of the nozzle in relation with each other. That's why if you touch those 2 screws that hold the sensor firmly coupled with the head, the old bed leveling data and Z offset should be considered invalidated and be reworked. Many people would shove a piece of paper under the nozzle, tinker with the Z offset until they feel it's right, and call it ready to print. For me, this is purely to make sure the nozzle doesn't pierce the bed the first time I try a calibration print. The actual perfect offset value is a process of discovery that takes several test prints and requires tinkering with the printer settings. More on that later. And this should have been it, right? The bulk of the work is done. I've done everything by the book and colored inside the lines, mostly. I should have just started printing without a care in the world, right? Wrong. That wasn't the case at all. All my test prints didn't behave as I expected them to do. And several times over, I thought I had the printer dialed in just for the next print to prove me otherwise. Filament was hooking to the head at the beginning of prints, randomly. The first layer was inconsistent one print from the next. Layer surface was coarse, and even in the best of cases, the printer failed to print almost anything above 5 mm or so. Inconsistency was the name of the game, and I started banging my head against the table. What have I done? Have I ruined my perfectly balanced printer? Probably. I got greedy and changed too much, and now I had too many unknown actors misbehaving. So I had no choice but to backtrack massively. Out went the silicone feet, and back in my favorite blue screws. Could the silicone be at fault here? I don't know, but I had too many moments when I felt the bed feels stable, but it doesn't behave like it's stable. Out went the hardened, unbranded nozzle, and in a genuine Creality brass one. If I look at the nozzles under the microscope, I see several problems. On the left, there is a hardened, unused nozzle. In the middle, there is a hardened one that I took off the printer, and on the right is the original nozzle of the printer, the one that I had since the very beginning, until that failed print I mentioned at the start of the video. What should become immediately apparent is the fact that the hardened nozzles are not blued, but painted, which in my book is a big no-no. And painted with something that degrades and sheds after heat exposure. It doesn't feel like brass underneath, or at least it doesn't scar as easily with the tip of my tweezers as the brass one, but it's definitely an unknown material. But the main potential problem I observed only under microscope is that the original nozzle has more body mass than the new ones by quite a lot, and the tip is at a shallower angle. Does this mean that the new nozzles don't retain heat as well, or the very tip gets too cold too fast? Maybe. That will definitely explain a lot of the issues I encountered. I thought this particular filament is compromised. I even cooked it for several hours. Anyway, while at it, I also tested the Z-rod support and found it to be a couple of millimeters too small, and instead of keeping the rod perfectly straight, it slightly bent it towards the frame.
Out with it.
And just like that, suddenly I was out of the storm. The skies magically cleared and the print started flowing. The whole process was clicking. Thanks the 3D Maker. For dialing in the Z offset, I use a rectangular print that I stop midway through the first layer. I quantify the result and adjust the offset down. I usually start far from the bed and work my way down. In this case, I also played a little with the extrusion steps. That's not usually necessary. Here is a print with the offset at 625, minus 0.625. Higher negative numbers means closer to the bed. And with the extruder set under at 96 steps. Not good. The weave is not connecting. This is a little sharp. Next is one lower to 650. Seems a bit better, but far from what I want to see. Next is the same offset, but with the extruder set at 97.8 steps, which I previously determined to be the correct number of steps, at least mathematically. No significant change. How about over-extruding by roughly 1%? Suddenly there are some good signs, but I don't feel that over-extruding is the way to go, quite the opposite. Back to the correct extrusion value, but the head lowered to 675. Even better, but still no cigar. And finally, with the head lowered to 685, the resulting weave was what I deemed to be perfect. I still believe that this printer works better when under extruding, because even at these perfect values, I whipped the calipers back out and measured the thickness of the first layer at 0.25, down from 0.28 of the first test print. I really need to take it closer to 0.2, or the second layer will not be as happy as the first one and potentially suffer for it. But for now, this is close enough. Let's start printing some. What's that? What's with the accidentally ruined axial motor, you ask? Never mind that. These aren't the droids you're looking for. I printed several CHEP cubes during this period, so let's see the results. The first cube is done in the old configuration with the hardened nozzles and with the rest of problematic upgrades. The main problem here is there is some contamination. This can't be from the filament. It must be from the nozzle shedding its paint. I also see a big difference on the last layer on the Z face, where there is an obvious improvement in quality on the second cube. And by the way, the other two cubes are done after removing all the problem upgrades and getting back to a brass and genuine nozzle. And at different points of me breaking loose and tightening to a proper level all the adjustment eccentric wheels in the printer. Yes, I serviced this printer several times over a short period of time. The next print is a Benchy, and I'm completely pleased with the result. This is at par with the best that this printer ever did, apart from the stringing. This is more stringing than I ever remember encountering. Next is the 3D printer mini test. I also think this is right up to this printer known standard, except for the excessive stringing and maybe signs of too much material extrusion in places. I definitely need to cut back on that. Finally, getting sick of the level of stringing, I decided to cook in a stringing torture test, whilst doubling the retraction level from within the slicer and reducing the filament temperature. Can you feel it? I'm finally back at the point where I can throw just everything at it and just print it, better or worse, but without fears of it getting stuck, failing to adhere or finish printing. What have I learned? Well, I obviously have too short of a memory and forgot how hard it was to bring this printer in balance back in the day. It's never a good idea to have too many balls in the air, especially if you're the one critically wounding yourself. Change things one at a time and test the hell out of every step before proceeding. Otherwise, I deem this to be still a good printer, albeit slow and quietly aging. Several sessions of cleaning and tightening wheels and races revealed me some wheels started to look worse for wear. There are nicks and dings, but surprisingly none where they contact the racing surfaces, so I don't think a complete replacement of all the wheels is required. None of the wheels act like they might become oval either. But the X-belt also shows slight signs of aging. If I over-tighten it, I can easily see white fine cracks in it. Probably not enough to consider it compromised, but replacement belts have already been summoned from the East. But at this point, this is me done for now, and I leave you with this. Remember your ABCs. Always be servicing,